Hey guys, Mr. Bowman here. Today's learning objective is in green and we are learning to calculate the area of composite shapes. So the area is something that we're all fairly familiar with. It's how many of those little 1 by 1 unit squares would fit into a larger shape. So you can chop that shape up. We focused on fairly basic and easy shapes. Today we're moving on to a new thing called composite shapes. And composite shapes are shapes that comprise of multiple other shapes. So shapes comprising of 2 or more other shapes. And I'll give you an example of what I mean. The most common composite shape you're going to come across is like these L-shaped ones that I've drawn here. And you can chop that a couple of directions. If you chop it down like this, you can see you've got quite a long rectangle with a bit of a square. And you can also chop it the other way where you've got a bigger rectangle up the top and a smaller rectangle down the bottom. That's a composite shape. We can see it comprises of 2 or more other shapes. We're going to focus on composite shapes that comprises of 2 shapes in this video, but do be aware the same rules can be extrapolated up to 3, 4, 5, and so on type shapes. So let's get into our first one. We're going to focus on question 1 to start off with. And the first decision you've got to make is where you're going to chop your shape up to make these 2 other shapes. So we can go along the bottom to make the kind of a square-like shape and a rectangle up the top, or we can make a big rectangle with a little rectangle on the right-hand side. We're going to stick with that last one just because it's already there. And what I'm going to do, just to help my working, I'm just going to label my shapes. So that's 1 and 2. So in our case, the area of our composite shape is going to be the area of number 1 plus the area of number 2. We now need to go ahead and think about the area of each of these shapes. So shape number 1 is a rectangle, and that's going to be simply base times height, which is 12 times 8. And we're going to add the area of the other shape. This one's a bit more difficult because we don't have the dimensions. We are going to have to do a bit of shape deduction to figure out what they are. And we'll start off with this side, the vertical side along here. We can see the long side here is 12. The side here is 7. That means this portion here has to be that leftover 5 meters. The same logic applies for the shorter side up the top. The long side is 11. The shorter side down the bottom is 8, which means the short side of our shape is 3 meters. So base times height is going to be the formula for that shape. So that's going to be 3 times 5. That there is going to be 96 plus 15, and that's going to get me a nice number, 111 meters squared. No rounding needed there. But hopefully you can see that approach I took. Divided the shape up, wrote down my equation, figured out each of the parts, and then I went ahead and evaluated my answer. So shape number 2, it's kind of been chopped for us already, but we'll chop it down there. And we're going to have shape number 1 at the top, which will be a rectangle. Shape number 2 down the bottom, that's going to be a semicircle. So we're going to start off by writing our equation. So the area is going to be equal to part number 1 plus part number 2. The area of part number 1 is going to be simply base times height. And the area of number 2 is going to be 1/2 of pi r squared. We're now going to do that substitution part of it. The rectangle is easy. That's 10 times 6. 10 times 6. The circle part's a bit harder because we haven't really been given any information about the diameter or the radius. We need to go ahead and find that out. But luckily, it's fairly straightforward. The top side over here is 10. The little portion on the right here is 8. That means the diameter of the circle, that portion is 2, which means that leaves the diameter of 8 up here. Half of that 8 is going to be 4, so we've got a radius of 4 centimeters. We're now going to substitute that in, so we're going to go plus 1/2 times pi times 4 squared. That's going to be equal to, this is where you get your calculator. As soon as you're dealing with pi, grab your calculator straight away. So 10 times 6 plus 0.5 times pi times 4 squared. And I'm getting 85.1 meters squared. This time around, I did have to do a bit of rounding, so I'm stating my 1 dp rounding. So we've done question 1, done question 2. We're now going to move on to the harder question 3, and I'm just going to clear my space here. So space cleared. I've also changed pen colors. I've got the red pen now. First step is you need to think about the parts of our composite shape. So I'm going to deal with part number 1 and part number 2. So we're going to set up our initial equation. The area of this composite shape is going to be part number 1 plus part number 2. We now need to go ahead and form a bit of an equation. So the area of part number 1 is going to be base times height divided by 2. And the area of that semicircle is going to be 1/2 times pi r squared. We now need to think about our substitution. This is going to be messy because we are working backwards to find out some dimensions. So I'll do that over here, but we know the area part, that's equal to 125. The base of our rectangle, we know that's going to be x, so the base will be equal to x. The height of our rectangle, that's going to be 3/4 of x, and our radius, since the base is x, the radius is going to be 1/2 of that, so 1/2 times x. We're going to substitute these 4 parts into our big equation, and we're then going to solve for x, because there should only be one variable in our equation. So here is 125. That's going to be equal to base times height. So that's going to be 1/2 times x times 3/4 of x. I'm now going to add 1/2 times pi times 1/2 of x, all of that being squared. I've now got a bit of simplifying to do, so there's a lot of fraction work here, which is going to be a bit annoying, but 125 is going to be equal to fraction times fraction, so top times top, which is 3/8 x squared, and then we're going to add this part here becomes 1/4 of x squared, and then that's going to be times by this 1/4 over here, so that's going to be 1/8 of pi x squared. We can see that the denominator of these are both 8. So that's going to help our case out. So we're going to have 125 is going to be equal to 3x squared over 8 plus pi x squared over 8. And now I can see it coming a bit together. I'm now going to add the numerators together. We may run out of working again. 125 is equal to 3x squared plus pi x squared, all of that divided by 8. We're going to move on up in this direction. I'm now going to go times 8 to get rid of that divided by 8. So 1,000 is going to be equal to 3x squared plus pi x squared. And we can see they've got an x squared in common, so we're going to factorize that. So 1,000 is going to be equal to x squared, 3 plus pi. And that 3 plus pi is a multiplication, so I'm going to move it to the other side as division. So 1,000 divided by 3 plus pi, that's equal to x squared. And we can get rid of the squared by square rooting the other side. So square gone, square root in. And once you've got that, you're going to put that into your calculator. X is going to be equal to 12.76 centimeters squared. So very messy question in terms of the algebra and the forming of the equations, but I really enjoyed that. Got down to a cool surd, which is that square root, and then we're able to get to our final answer at the very end. So guys, hopefully you enjoyed this composite shape video. I find the algebra that can come out of these really fun. Hopefully you do as well. Now let's get into heaps and heaps of practice.